The broadcast is now starting. All attendees are in listen-only mode.
Welcome to APICS Extra Live, Optimize Spare Parts Inventory and Service Levels, based on an article in the most recent issue of APICS magazine. My name is Jason Giovanno, Research Manager with APICS. Before we begin, I'd like to run through a few details. At the end of the presentation, we will save time for a question and answer session. If you look at the right toolbar on your screen, you'll see a question box. To ask your question at any time during the presentation, simply type it in the box and click send. If you experience any technical difficulties during today's broadcast, please call GoToWebinar support at 1-805-617-7000. This presentation is being recorded and will be made available for download through the APICS website in the near future. And now, it's my pleasure to introduce Jozo Acksteiner and Sean Tay from Hewlett-Packard.
Hello, everyone. Good evening, good morning, good afternoon, wherever you are. Thanks for giving us the opportunity to give this webinar on the article that we recently published with the APICS magazine. So let's get started. Next slide, please. So a quick introduction of ourselves. My name is Jozo Acksteiner. I'm with HP since 2010. You see here I'm in a team which is called SPAM, Sean as well. SPAM stands for Strategic Planning and Modeling. We'll introduce the team a little bit later, so you will see that the team is much longer around than SPAM emails. And that's the reason why we kept the name, because it's quite a recognized brand inside and outside of HP. Next to HP, I'm also professor at the National University of Singapore, co-founder of a startup called geolix.com. You see here a couple of details of my past, but let me hand it over to Sean. Sean?
Yes, great. Thanks so much, Jozo. So Sean Tay, I've been part of Hewlett-Packard HP since 2007 here in Singapore with Jozo. So both of us are based out of Singapore, and so you'll see a lot of the work that we're going to present has reference to Asia. That's because that's our area of focus. I've been in supply chain for about 20 years now, and have worked in a number of companies, which you'll see listed over there, as well as Hewlett-Packard. And prior to that, I was in school. Of course, I've got my education, an MBA from Canada, where I'm from. And I should mention I've also been in Singapore since 2007, and originally from Canada. So maybe we can move to the next slide. Great. So this is what we're going to talk about today. I'm going to give a quick introduction to the HP supply chain, and specifically to the service parts supply chain. And then Jozo is going to talk about the strategic planning and modeling team. And after that, we're going to go right into the details. So the first two items in the agenda there take about 5 minutes, and then we'll quickly go into the meat of this presentation, talking about how you can optimize your service parts inventory. So let's move to the next slide real quick. Right, so HP has the largest IT supply chain in the world, and it's at last count, it was a $120 billion supply chain, and a big chunk of that is supply parts. And if we could go to the next slide, we'll quickly talk about what our service parts, our service supply chain looks like. So within Asia, right, we've got hundreds of service centers. We use a hub and spoke system where we have a regional hub, and this regional hub services country hubs, which then service field stocking locations or service locations within the countries. We could have up to 70 service centers per country, and we have tens of thousands of parts in each of these locations. We have huge amounts of inventory. Well, you'll see some of the in some of the slides we talk about like tens of millions of dollars of inventory. So a little bit of improvement goes a long way within our supply chain. Let's keep going. All right, and Yozo's now going to talk about the strategic planning and modeling team, and then he'll keep on going to the to how you can analyze your service supply chain. Yozo?
Thanks, Sean. So yeah, let's cover a little bit about the strategic planning and modeling group. Next slide, please. So the strategic planning modeling group is an analytics in-house consulting team to HP. We are only doing projects for HP, so we are not selling our work externally. We are a worldwide team of 15 people. We have a mixture of analytical consulting and technical skills that we bring into HP. So the team is around since over 25 years. That's why we kept the name spam, although sometimes we still get into in the team some emails addressed with help us with our spam emails. That's not us. We are helping on big analytics projects, typically with an impact of several $1 million. So really high impact analytical problems that we solve. In addition, things that we do today, developing innovation, publishing is some extra work that we are doing. So it's quite an interesting team, long time around, and yeah, I'm very happy that we are able to introduce us here. Thank you. So next slide. So now let's go into the meat, right? Lessons learned from service supply chain data analysis. So when we talk about service supply chains, the first thing as a consultant that you hear when you enter a project about service supply chain, in particular when you talk about inventory in service supply chain, is don't touch it. You know, if you touch the inventory in service supply chains, you directly hit service levels that impact customers. And of course, the main thing for a good service supply chain is to provide high quality to service levels to customers. If you miss those, then it's directly not only a disappointed, unhappy customer, but it can have significant impact here to the customer's business. You have to see that when we talk about service supply chain for HP, it's not only the small printers and small computers that we are talking about here. No, we are talking here about big servers, room-filling printers that do digital print. So if these machines stop, it's directly a big impact to the customer. So the first reaction then when we get into such a project was, don't touch it. Don't touch the inventory. And you will see on the next slides, and this is what we are trying to convey here, is yes, there is a way how to intelligently manage the inventory in order to not being hit by a lot of bound cash in your inventory, but at the same time to improve actually the service levels. So as a result of projects that we did, we were actually in some businesses able to reduce the inventory significantly and increase the service levels at the same time. Now that sounds at the beginning maybe a little bit counterintuitive. How could you do this? How can you reduce inventory and at the same time increase your service level? And this is what we will try to explain here on the next couple of slides. So let me start here with a typical Pareto analysis of service parts. You see here a curve. This is, of course, all these numbers that you see are disguised. We cannot share any actual HP numbers, but it's kind of in the ballpark of what you can expect, what we found in several projects in several businesses inside and outside of HP. So on service on service supply chains, well, coming from consulting, I should say, you're used to the 80-20 rule, right? 20% of your products make 80% of your business, or 20% of your customers contribute to 80% of your revenue. Well, what we found is that when you look at spare parts distribution, you have actually not an 80-20 rule, but almost a 5-90 rule. So let me explain that a little bit. As you see here at the x-axis, the parts, several thousand parts of a business, and then the volume distribution if you add all these parts up, so a Pareto analysis here. And you see the high-running parts, which is only 2% of the total number of parts, just a few parts really in comparison to thousands of parts, make 80% of the volume. That's striking, right? Only 2% of the parts make 80% of the volume. Then another additional 3% of the parts make up another 10% of the volume. So with 5% of the parts, you cover 90% of the volume. Okay? And then you have, of course, the long tail of low runners, which make 90% of all the parts, but only do 10% of the volume. So this is something that is definitely something different than what you would see in other normal volume businesses, but something that we found pretty typical in spare parts. Now, what does that mean? It means also your service level is dependent on very few parts really, because if 80% of the volume have an impact to your service levels, then this means this service level is determined by these 5% of the parts, right? 5% of the parts make 90% of the volume. 90% of the volume means also 90% of your service level is determined by these 5% of the parts. In addition, what we found is a very interesting concept of what we call insignificance barrier, which is here indicated by the light blue box. This would mean this long tail of parts that have a very little usage, those are sometimes facing a volume of maybe just a few parts a year in whole Asia. So it was when we did this analysis, we looked into that, we found that in some parts for whole Asia would maybe have a demand of 1 for whole Asia, or 2 or 3. Now what does that mean? Well, typically, when you prioritize parts in terms of you want to see which is the most important part for the customers, right? But if you have a demand of 2 this year, no one can tell you if maybe next year is 0, the year after is 3. So you have these thousands and thousands of parts that you cannot sort anymore by volume in order to determine, are they really contributing much to the service level or not? This becomes very important when you come to stocking strategies, because for those parts there's no order anymore. It's basically arbitrary to say, well, do I store this part that had a demand this year of 2, or do I stock this part that had a demand this year of 3? It's virtually no difference. Okay. The last point here that I want to stress on the slide is this is a very simplified view of the world, of course. It's just based ranking importance of parts by volume, which is, of course, not the case. Some parts are more relevant to running a machine. Other parts are less relevant. The machine can even run without that part. We'll come to that, and Sean will cover that in another section a little bit later. But keep that in mind. Let's focus though for a moment on these very specific Pareto and volume distributions. Next slide, please. So these very, very distinct volume distribution has a big impact on the cost of inventory. And you see this here displayed for the high running parts, medium running parts, and low running parts. Again, these numbers are not HP, they're disguised. However, you will find in spare parts businesses that, you know, this is something that you can face. So let's take a look at this, right? The y-axis, the height of the bar charts display how much inventory-related costs you have for a part. So a high runner here in this example would cost you $33. Medium runner would cost you $75. A low runner could cost you $387 for stocking. Why is that? Well, I told you sometimes you would have in whole Asia a demand of this specific part of 1 or 2 or 3 a year, which means that you have, if you want to stock it, if you need to provide it in country, because in Asia you need, if you want to provide a part, for example, next business day, you have almost no choice. You would have to stock it inside of the country. You cannot import it and deliver it within a day. It's just impossible in Asia, right? So you would have to stock this part that you have a demand of, let's say, 1 a year in whole Asia in all countries where you potentially need this part. And you easily come to a conclusion that there's a demand of this part in that specific country of maybe 1 in 10 years. So this makes these very, very high costs of inventory. And compare this to the high runners, right? It's a tenfold increase of the inventory-driven cost only. Now compare that to warehousing shipping costs, which is the dark blue line that we just put in here for comparison, right? It's significantly more expensive to stock a part that is a low runner with this profile than the production, the warehousing, the shipping, everything together. It is way more expensive. So you see already where this is a little bit heading to, right? Providing the stock can be extremely expensive, right? You cannot stock less than 1 inventory unit, right? I mean, you cannot, if you have a demand of 1 part in 10 years, you still have to stock 1 part. You cannot stock 1/10 of a part. And these low-running parts cost you a lot. But remember, they only contribute to 10% of the overall service level. Now, still somehow you need to provide these low runners, right? So what do you do with it? And we'll cover that on the next slides. So let's go to the next slide, please. So the first thing that is maybe different in service supply chains from other normal push and pull supply chains is that the tendency that if you need to cut, right, every one of us has faced situations where there was a business drive to cut inventory, right? This is just the normal life of a supply chain manager. You need to reduce inventory. You figure out how. Now, if you cut inventory, tendency is, of course, to cut inventory where you have most of the inventory. But you will see that this is a very bad decision when it comes to service supply chains. So let me demonstrate that here on this chart. You see here on the left side what we call a hit-miss analysis of the service supply chain. So again, simplified, here in this example, we have a 90% hit rate. This means 90% of the time the delivery was okay, everything went fine, and there were 10% that had a miss. Now, we need to break this down. How much comes through stockouts? How much comes through logistics? How much comes through IT and other reasons? You see here in this example, 7 out of the 10% come out of the stockouts. So theoretically, if you would be able to resolve all the stockouts and always be able to provide stock, you could theoretically hit a service level of 97%. Okay. However, remember, this would also mean you need to stock all the low runners, and this can be extremely costly. So the next thing that we do, or that we did, is examining the stockouts themselves. And here you see a breakdown of the stockouts into low runners, medium runners, and high runners. Now, generally, we said, right, the high runners make 80% of the volume. They only do 76% of the stockouts, so lower than the volumes, lower than the volume that they provide. The low runners and medium runners together make 16 plus 8, so 24% of the stockouts. So slightly higher than the volume that they provide. However, remember, it is much cheaper to stock high runners. So what we are recommending here, what we are seeing here, if you want to increase the service level through stocking, you want to stock on the high runners first, because they contribute still a lot to your service level, right? If you just say, oh, I want to focus on all parts, yes, you would focus on 95% of your parts, but you won't gain much, right? So what this says, you are never allowed to stock out on high runners. There's no excuse to understock on high runners. Coming back to the initial question on the slide, inventory target reductions never reduce on the high runners, because if you reduce stock on the high runners, you will directly feel the impact on your service levels. Okay, so let me go to the next slide. Now, here you see another interesting chart. This is basically giving the counter perspective. Now until now we have focused on volume, and you still see the volume curve here displayed as the dark red curve that is very flat and is displaying this situation that 5% of the parts make 90% of your volume, right? So you see the curve is absolutely flat until 5% of the top 5% of the parts, and then all of a sudden it skyrockets in terms of demand, right? So the red curve is really almost looking like the XY axis here, but it is really the volume curve of the parts, or demand curve of the parts. Now, the blue bars on the other side is the inventory, and this is really an inventory map of all the parts that are displayed here. And you see, by tendency, the parts which have a higher demand have also higher inventory. Well, that's good. That should be the case. But you also see that there's a lot of stock, 70% actually of all the stock is on low volume parts. And these low volume parts do not contribute or contribute only to total 10% of the service level, right? So 70% of your stock in this chart contribute to less than 10% of your service level. Well, there's a room for improvement if you have any alternative. I mean, there's no way around. You have of course, to provide service to your customer. So you cannot just say, oh, I don't stock on these parts. But what you want to do is to focus on this very, very expensive inventory that you have there on the low runners, and see what can you do. And here are just a couple of suggestions, a couple of things that we looked at. One is, of course, centralize and expedite. Sean will demonstrate that later. There's a very interesting analysis you can run on this, when it is worth to pay the extra money to send parts with courier. Wholesale partnering. This basically means, can you locally purchase the stock when you need it? Customer kits. Can you provide some of the parts directly to the customer as very important parts that are important to run the machine and that always are needed, so that the customer has the part directly on site. Of course, you can go into the research and development, right? Reducing the overall number of parts. This is clearly something that the automotive industry is facing since a long time, and this is certainly something here that you can do, but this is more a long-term shot, of course. Increasing the reliability of parts. Right? These low runners that are very important, but that are also very extremely expensive to stock. You might be able to invest more in a higher quality part here and save then the cost on the inventory. Or 3D printing, certainly a hot topic now. There are several approaches to this. The airline industry is doing this already, and we are sure this will be flowing into other industries as well in the near future as 3D printing of parts evolves. Okay, let me go to the next slide. Yeah, so we will see now what to do with this. How can we optimize this? And Sean will take you through this and show you a couple of approaches that we tested out. Sean?
Great, thanks so much, Jozo. And so what I'm going to be doing now is talking at a higher level, and then I'm going to drill down on some of the approaches you can take to optimizing your services supply chain. If you could go to the next slide, please. So the first place to start is the commitments that you have to live up to, right? This is really the sales operations interface. The bottom line is the operations team has to live up to the commitments that the sales team makes, right? They write the checks that you have to cash. And if you're talking about large enterprise size devices, for example, if we're, like Jozo mentioned earlier on, it could be a server, right? It could be a printer, a press that is the size of a warehouse. If you sold one machine, or you sold 3 machines, or you sold 2 machines, right? The inventory of your service parts does not double. So if I sold one machine and I needed $26 million or $26,000 of inventory of service parts for this machine, let's say country D in the example, and I sold 6 machines in country A, right? It doesn't mean that I need 6 times the inventory of service parts in country A. Because if you remember the chart that you saw earlier on, a very high percentage of those parts are actually slow moving. So it actually only keep one part, whether you had 6 machines or 1 machine in the country. Now, if we look at this, right, that what this means is that if you're in a region like Asia or Africa or South America, where there's a lot of emerging economies, right, you could find yourself selling 1 machine and making a high service level commitment for that single machine. And it could be a country where you would never sell another machine. And if you have a situation like you see on this chart where you have 6 countries, right, each of them with 1 machine, you would end up with 5 times the inventory of service parts that you would have if you had just sold the 6 machines in one country. So what does this mean? We're not saying don't sell the machines there, right? But there needs to be a discussion with the sales side. Like, if we sell this machine in this country, how likely are we to sell more machines in that country? And at what point do we, what's the target number of machines before we can start offering that high service level? And if we think, this is going to be a one-off deal, we're only going to sell one of these giant presses in Bangladesh, and that's all they're going to need for the entire country, right? Then don't write a service level contract that says we're going to get the part to you if your machine goes down within 3 hours, because that guarantees that you have to put the inventory in that country, right? Write the contracts in a way that you can service it centrally, or service it in a reasonable way. Now, if we move to the next slide, please. Right. So as we talk about, we've now got the machines in there, we've got the inventory stocked in there. Well, where can we draw down inventory, right? How do we balance our volume and how do we balance our service level commitments with our inventory targets, right? And again, this is where you basically group your products and you put them on a matrix, right? Now, if you remember the earlier slide where we saw that a lot of inventory or a lot of the parts were slow-moving parts. Well, not all slow-moving parts are made equal. You've got high criticality slow-moving parts and you've got low criticality service parts, right? And with the high criticality parts, it's understandable to maintain a high level of service commitment. So here's the example of GIF, right? That you could have a little screw or a wheel that fits inside the motor of a printer, right? This part could be, because it's very, very critical. If it breaks down, the whole, $10 million printer stops working, even though it only costs 50 cents. Well, this part is going to be built to high standards and high tolerances, right? It's a small part. It only costs 50 cents and breaks down once every 10 years. But when it breaks down, you got to be there to fix it right away, right? You compare that to the screw on the panel that you open up and you put paper in. Well, if that jiffs, so the door doesn't close properly, the machine still keeps running. So you don't need a high service level commitment to that. So the first thing you need to do is group your products. You got to know which ones are don't just group them by volumes. You got to know what the service level commitments are. You got to know the criticality of this part, right? Which we do in HP. And that allows us to cluster our products into a matrix like this. So now we know, these are the low volume parts, right? The slow moving parts, and they're not very critical. Well, then how do we optimize our inventory? If you're going to start with, at some point, to reduce your inventory, well, that's where you start. Low volume, low service commitment parts, right? And again, there needs to be an interface between operations and the part of the business that deals with the customers, right? Either the service centers, the sales sites that say, we're going to write our contracts in a way that if your part is critical, we will be there for you, right? If it goes down, we'll be there to keep your business up and running. But there's parts that are not critical, right? That screw on the door does not need us to be there tomorrow, or it doesn't need us to be there in an hour. We could be there in 3 days, your machine still keeps running. So figure out where all your parts are, and then you can take action against, you can prioritize what you want to address first. And be aware that even after you do this, right, and you start taking action to draw down your slow-moving parts, it could take a long time to draw down your inventory of low-volume parts. We have parts, right, that could take, you only have one part in the service center, but that part only breaks once every 5 years. Well, it could be 3 years before that part actually gets used. So with service supply inventory, service parts inventory, execution, from the time of execution to the time of impact, you got to expect a little bit of lag there. That's what you got to manage expectations on in management when they tell you to draw down your inventory. Now let's move to the next slide and talk about what you do after you know where your products, where your groups of products sit. So what you then need to do is look at what it costs you to provision these parts. So I'm going to explain this chart first, and then I'll talk about how you can execute it. Now, the purple line is what we define as traditional warehousing, right? That is the kind of stocking where you put your parts out in what we call field stocking locations. So these are the service centers that are out in the cities that are close to our customers, and you can provide service within 4 hours or 1 day, depending on how we write those service level contracts. The next line that you see is the yellow line. That's the centralized stocking. So in this case here, it could either be centralized inventory in a country hub, or it could be centralized the inventory in a region hub, right? So then what you would do is actually centralize it and expedite freight. What Yozo defined as courier freight, right? It's some form of freight where you get it there. You pay more for fast shipping, right? And the last thing we have there is customer kits. In the enterprise system, right, when you sell to enterprise customers, you could have a situation where the customer pays for the parts when you bring it in. So it's not like their consumer laptop where if my laptop breaks down, I bring it into the service center, it's still under warranty, they fix it, they don't charge me for the part, right? But we're talking about a situation where the customer pays for the parts when it breaks down. So what you could do, right, is then get the customer to buy a kit. So keep the inventory on the customer side, right? But there is still a cost to provision that, right? So you put that on the chart here. So now you have your cost of provisioning by volume, okay? Now what you'll see here is that in the traditional warehousing approach, the greater your volume, the lower the cost per part of provisioning it or delivering it. And I apologize for the axis over there. Some of the fonts got shifted around when we transferred this, but it's basically, if it's a low demand part, it costs you more to stock it in a traditional warehouse. Now, if you remember Yozo's curve, right, the one that showed that you've got parts that have very low demand, right, and those low demand parts make up the bulk of your inventory. Right, so you actually get a double whammy here. You're stocking it in more locations, so it's costing you more, and you've got a lot more of it, a lot more of the inventory. So as you move down the line, as volume increases, you get to the point, right, where it is cheaper to centralize it than to, it becomes more expensive to centralize it than to store it in a traditional warehouse. So fast, high volume parts, right, will be more expensive to centralize because you're paying a lot more for the expediting for those parts. If I only have to expedite it once every 3 years versus I have to expedite it every day, that's a big difference, right? So the faster moving parts, you want to stock them out in the location, in the field stocking locations, in your forward locations, and the slow moving parts you want to centralize as much as you can. You can't do it with every single part because you've still got the service level commitment, right? And the last thing is the customer kits. How much does it cost to put it out to the customer? So that cross point over there around 9, right? 9, the demand part's 9, about $200 on this chart. Now these numbers are purely illustrative, right? At that point, that's where you start saying, okay, the parts that are slower moving, that are not critical, I'm not going to put it in my forward stocking locations. I'm going to centralize it. Okay. the area that is below that, right? The area below the cross point, the area below the purple line and the orange line, that is the cost differential that you have between stocking it at getting your customers to take it and stocking it yourself. Now, the customer is of course going to have their own cost of inventory. So you're not going to be able to just say, take this part, right? We'll sell it to you. Just take it and keep it in your part. When it breaks down, right? Just call us. Well, actually, for most part, if it's an enterprise system, there could be an on-site person. So your IT guy or your maintenance guy can fix this with the part on site, right? So what you have to do is incentivize your customers to take the inventory on hand. And having this chart gives you the knowledge on how much incentive you need to give. The gap between the blue line and the orange line or the purple line, whichever is the lower, right, is how much incentive you can offer to that customer to take on the inventory before it would have been cheaper to just store it yourself and ship it to them. All right, so that takes us to the end of our prepared material. What we'll do now is take questions. And let's see. Okay.
Shall I start, Sean? I
Yeah,
already
can you
looked
see
at
the questions? Yeah,
Yes.
if you've been looking at the questions.
So there's a very interesting question that I see here. What is the time interval you're considering for low, medium, and high running parts? That's a very good question. Short answer is there is not a cookie cutter approach for this. But you need to consider, so for example, in one project we started in looking at quarters as time interval. But then we figured that the number of parts we had was so low that the statistical significance of this low number would not be sufficient to do any recommendation. So then you have to increase the number, to increase the time interval just to get a bigger data set. On the other side, you don't want to make the time frame too long, right? The other extreme is, okay, now if I'm not allowed to have a very short time frame, can I take a very long time frame? Well, if you take a very long time frame, you have the disadvantage that the business is changing. So some of our businesses in HP are relatively stable, right? Then this wouldn't be a problem. But some are significantly increasing. If you're in a business that is growing year over year 50%, then you cannot afford to look at too long time intervals.
Yeah,
so
I'd say the short answer to that is that that time frame is directly correlated to the lifespan of your product, of the life cycle of the product. The longer your life cycle, the longer the time frame needs to be. Should we take another question, Yozo?
Sure. Do you see the questions, or should I just?
Yeah. Sure. Okay, so how do you figure parts going obsolete? I think we can figure in parts that are going obsolete. So, well, I think this question means like if of your service parts, sometimes your products are going to go obsolete and the parts are going to go obsolete. I believe that's what that question means. So what you got to do is, it's not just a matter of the parts going obsolete, because this is not like finished goods inventory, right? Where the product goes obsolete and then you clear it out for where you just clear it out on a sale because you've got a new product coming in. This is service parts, right? So it's actually the life cycle of the parts that you keep is actually based on your service commitment to the parts. So, for example, if we're looking at a consumer printer or a consumer PC where we would have a 2-year commitment to it, what we would do is actually we have a pretty good idea of what parts break down and to what to what extent and how long their lifespan is. And we also track our printers, or our printers, our PCs. We track the sales of our products through their life cycle. So we actually will forward stock our service parts for these items. Now, at some point, if we're talking about consumer product, it is actually it becomes cheaper to just say, you know what, we're going to cut off the inventory of service parts at this point, right? These are parts that, there are some parts that are transferable to the next version of the product, right? So we continue to stock those. But there are some parts which are unique to this model. And this model goes up, so is ending its life cycle at this point, right? And from this point, there's still, we'll still continue to sell it because it's out in the channel for another X number of months. And then after that, from that last point, this is the number of units that are live out there that we would have to service. And you actually stock parts out for that. And at some point, you cut it off. And you say, look, it's not, we want to deplete all our parts by this point. And if we mistime or we misforecast the amount of demand for this, then what we are going to do is just replace the unit wholesale, because it's cheaper to just replace the complete unit than to have to stock the parts for it. And that's really where your forecasting and your decision making, and that's where you call in your analysts to do that math.
Okay, I see here another question, a quick one. Let me just cover this. What is a customer kit? This definition of customer kit is something where you have the chance to have the service part available at your customer site. There are different notions of this. In HP, we call these customer kits, but basically it means the customer has the part on site in a kind of emergency, store for failure. So that was a quick question. Another one here, to my understanding, the optimized service level is the service level for the all service parts. Did you optimize the total service level in terms of category, parts, demand, and parts cost? Yes. However, you need to take into account that sometimes you need to break the parts into different categories, because within parts there are different importances for parts. There can be parts that are critical for running the system, or for example, in a computer, the CPU, or parts that are not so important for running the system, for example, a label, or maybe even some type of maybe one USB port that is broken. So you need to break down the parts, the service level on the parts, not only by the volume. That we mentioned that would be too easy just to use that to use that approach. You also need to include what is the service level required on this part. Sean,
So
do you have another one?
there's a question here. To my understanding, the optimized service level is the service level for all the service parts. Did you optimize the total service level in terms of category, parts demand, and parts cost? Maybe that's the one that we can show them how we optimized all the scenarios and service level.
Oh yeah, that might be a good idea. Yeah,
that's a good one. Yeah, Jason, could you move to the slide that's right after questions and answers? I think we have one slide there. Yeah. So the short answer to the question is yes. We optimize it across the total service level, right? So you take into consideration, what you do is you actually create scenarios, right? So a scenario is, the way I would define a scenario is you group all your parts, right? Like I spoke earlier, and you say, for this group of parts, I'm going to put it in this segment. I'm going to put it in. So for let's just say group A is low volume, low criticality. So I'm going to in this market, put it in the centralized location. In this market, I'm going to put it in a regional hub, right? So that's a scenario. And the way we optimized it, right, was we actually took every single possible scenario and we calculated what is the service level impact and what is the inventory impact on it. So what you see on this chart here is the output from that calculation. There's actually two ways you can go about doing that. The less computing intensive way to do it would be to say, let's get your steering committee together and agree on 5 or 6 scenarios that you think are the best scenarios. And again, a scenario is that stocking approach, right? The stocking plan, stocking strategy, right? You then take and then you actually calculate the inventory impact and your service level impact for just those 4 or 5 scenarios. We started down that path and we realized that there are actually tens of thousands of possible scenarios, and there was always another hypothesis that would surface in the management meetings on, did you try this other approach and why don't you go back and do that? So what we ended up doing was the second approach I'm going to talk about. You build an algorithm I guess you build a program that allows you to calculate every single scenario. So in this case here, we calculated 70,000 possible configurations, right? There would have been more, but you actually take out stocking strategies which are unrealistic. So if a certain stocking strategy has you putting parts that are critical in locations that do not allow you to hit the target service level for those critical parts, that strategy is out. So of what we remained as realistic strategies, that we had 70,000, right? We charted all of them as you see them on this chart, and then you draft out the efficient frontier. So the efficient frontier is for any given level of miss rate impact, what is the maximum inventory impact I can get? And that's what that black line is, right? So if somebody came back with a scenario and said, what about this? This one's, what would you consider this scenario? You could say, well, the miss rate impact for this scenario is at that point, and actually for that level of miss rate impact, right, you could actually get this much more inventories impact by using this other strategy. And this changes the conversation, right? The conversation shifts from becoming, well, why don't we try this scenario instead? Why don't we try this strategy instead? To, all right, we now know what is the maximum impact we can get for a given service level impact, right? What's the maximum inventory savings we can get if we're willing to sacrifice a certain amount of service level? Then your conversation focuses around how much service level impact are we willing to take, right? And how much savings can we get out of that? Or, this is my target. Management, you're telling me this is how much inventory I have to take out. This is how much our service level is going to be impacted based on your objective. Now, are you willing to live with that sacrifice of service level? Okay, so I think that addresses that question. I believe we have one more question. And, and Jason, at the end of this, I keep seeing this maintenance point question show up on our list here. So I'll let you address that one at the very end of this meeting. Yozo?
Yes, here's an interesting one. Do you have employees doing this on a daily basis? I like this because it's coming back to how we are running our team, and maybe this goes a little bit into how generally our team is functioning together with the business. So short answer, yes. There are people, demand planners, and inventory planners, planning teams, actually several planning teams for different businesses that take care of which parts to stock and where to stock and which parts to stock and how to run the whole operations. Now, our team is coming in there to help them. This is exactly what the team was built for. Not every planner needs on a daily basis to do sophisticated analysis that what you see here, right? To do such a model that evaluates automatic different stocking strategies is not something that you would demand from a planner who's planning inventory on a daily basis. So this is when our team is pulled in. We know that there's an issue here. Maybe we have a lot of inventory, or we have a problem with our service level, or what can we do with it? And then we run our model mixed together with the demand team in order to provide such models. So why we are doing this and why is doing that HP internally? The reason is that we have a relatively fast ramp up time because we know the businesses, the people trust us. We're not coming in to do anything that is against their will or anything like this. No, we always work in mixed teams together. We learn from the teams on the particularities of the business, of the specific problem, and they learn from us the methodologies here in order to address this problem. So very often the models that we develop then also flow into the business so that they can be used also then on an ongoing basis.
So I see it's about 3 or 4 questions around how do we predict demand for the very low volume parts. And I see questions asking us for the formulas. So we don't have time to show formulas, and I'm not even sure we're allowed to. But what I would say is if you do a Google search for intermittent demand parts, there's a lot of material out there with formulations on how you forecast demand for intermittent demand, low intermittent demand. That's what you got to look for. And I also see a lot of questions from our I think they're HP colleagues because I see them using HP acronyms here. And you guys can just drop us a note. And for everybody else, you can track us down on LinkedIn if you have something, an urgent question that you need help with. So, I think we still have another 2 minutes left, so we can. Jason, do we wrap up? And I think there's some. Did you have to do a wrap up, or do we take one more question?
Feel free to take another question if you'd like.
Okay. Yozo, is there a question there that jumps out at you?
There was a follow-up question here. Is the customer kit inventory owned by the customer or owned by the service provider? Again, this is something that is going into details of the business. Just a general, and we would not be able to answer this here in this forum. However, this is something you want to take into consideration, right? You saw the chart where it costs you, of course, much less money as a company if you don't have to stock the part, right? So and there's another question here on small businesses. How could they not have too much inventory? So you really need to see which of the alternatives that we published here from customer kits, so stocking the part on customer side, to express supply chain, to maybe sourcing it if it's not such a special market, or even 3D printing, and do the math behind it. That's really the recommendation here, to know what it costs you to stock, because this determines the price that you're willing to pay in order to look for an alternative. One thing is sure, I mean, it is clear that using an alternative express shipment, 3D printing is expensive, but you need to understand what's the cost that you have on that part if you stock it, and then you can make the comparison, make the call, what you do with the part, and if how much you're willing to pay for that. Okay, I think we are on top of the hour, Jason. So I see many more questions, but I think we cannot answer them all. So I hope we group them at least in such a way that most of your questions get answered.
Okay. And a question that always comes up is, does the spam team do consulting outside of HP? No, we do not. We're an internal consulting team.
Well, that's about all the time we have for today. We'd like to thank Yozo and Sean from HP. This concludes today's edition of APICS Extra Live. All content and materials included in this edition of APICS Extra Live are the property of APICS and Hewlett-Packard and are protected by the United States and international copyright laws. All rights are reserved.